Welcome back to Go Figure. Today we're on lesson 40 of Saxon Algebra Half, Reciprocals, the multiplication rule and division rule of equations. Here are quick warm-up problems. Go ahead and pause the video and maybe just answer these out loud, and then we'll go through them. Okay, rewrite 8 as a fraction. Remember, any whole number can just be put over the number 1 to be rewritten as a fraction. So 8 would be 8 over 1. What is the reciprocal of 2/3? Remember, reciprocal is when we just flip a fraction upside down. So the reciprocal of 2/3 would be 3/2. And lastly, multiply 5/6 by 6 over 5. So there's a couple ways we can do this. We could just multiply right across and say it's 30 30ths. Or what would be better or easier would just be to cancel out some of our factors, and you'd end up with 1 over 1 times 1 over 1, which is 1 over 1, also known as 1. Okay, our learning objectives today. We're going to use the property of reciprocals to solve equations. And we're going to define and identify a coefficient. And we will apply the multiplication and division properties of equality to solve equations. So reciprocals, again, just to review, we just invert a fraction to find its reciprocal. And all whole numbers, except for 0, have a reciprocal. And the product of a number and its reciprocal is 1. So again, so let's say you have 2/3. Its reciprocal, just turn it upside down, is 3/2. 7/4. Its reciprocal is 4/7. And if we multiplied a number by its reciprocal, you will always end up with the number 1, because 2 times 3 is 6, 3 times 2 is 6. That would simplify to 1. Same here, 7/4 times 4/7, you would get 28 over 28, which is 1. And all whole numbers can just be put over the number 1. So let's say you have 9, and you can just put it over 1 to make it a fraction. And therefore its reciprocal, the reciprocal of 9, is going to be 1/9. So knowing this property of reciprocals and the fact that if you multiply a number by its reciprocal, you get 1, this is going to help us to solve equations that involve multiplication and division. Now, a coefficient, this might be a new term. So when a variable is multiplied by a number, that number is called the coefficient of the variable. So here I have a few examples. So for 5x, 5 is known as the coefficient of x. 2.9 times x. 2.9 is the coefficient of x. Here I have a fraction, 2/3 x. 2/3 is the coefficient of x. And sometimes this will happen in your book, or you'll see where, let's say you have a variable divided by a number. So you have x over 4. Well, what is the coefficient here? Because there's nothing in front of the x, right? Well, you can think of when you see a variable without a number in front of it, you can think of it having this invisible 1, because 1 times any number just leaves you with that number. So 1 times x is x. We just don't write it because it's not really necessary. But the way you would think about what is the coefficient of x here, the coefficient here would be 1/4, and you're multiplying that by x. So sometimes you'll see that, just know that that's how you would find the coefficient. And then -8x, -8 is our coefficient here. So again, it's just that number that comes like right before a variable when you're multiplying. So the multiplication rule for equations, very similar to the addition and subtraction rule that we learned last time, both sides of an equation can be multiplied by the same number, except for 0, without changing the solution to the equation. This is also known as the multiplication property of equality. So again, if you have an equation, to keep it balanced, you can multiply one side of the equation by a number, and to keep it balanced, just multiply the other side of that equation by that same number, and the equation stays balanced. Remember to think of the scale. What you do to one side, you need to do the other to keep that nice and flat. And then I will point out this except 0 here. So when I was talking about reciprocals, all whole numbers except for 0 have a reciprocal, and I'll show you that because let's say we have 0 and we write it as a fraction, 0 over 1, just like any other whole number that we would write over 1 to make it a fraction. If we wanted to find the reciprocal of this, we would have to invert our fraction, which would be 1 over 0. But 1 over 0 we actually can't do because we can't divide by 0. That actually is not a number. We can't divide by 0. So that is why 0 does not have a reciprocal. So the point of that is that when we have in equations, you can multiply it by any number, just not 0, to keep that equation balanced. Let me get rid of that. Okay. So when we're using this, we're going to multiply both sides of the equation by the reciprocal of the coefficient of the variable in order to solve. So that might sound very wordy, but we'll see when we get into practice here. So here's our first one, 8x equals 56. So that means 8 times something equals 56. So I want to use that reciprocal rule, and I remember, just like when we were doing addition and subtraction equations, we're trying to isolate that variable, trying to get that variable all by itself. So here I am multiplying, my coefficient is 8. So I can get rid of that 8 or isolate my variable by multiplying by the reciprocal of 8, because, so I'm going to make another line. So the reciprocal of 8 is 1/8. And if I multiply that by 8, which is to say 8 over 1, that's going to, and remember we said a number multiplied by its reciprocal equals 1. And then we have x here. So we're left with 1x on this side of our equation, on the left side of our equation, which again, we don't need to keep this 1 here. We don't need to show it. It's just extra. So we're just going to simplify that to x. And then that's going to equal 56, the right side of our equation. But what we do to one side, we need to do to the other. So we multiplied the left by 1/8. I need to multiply the right by 1/8. And this might get confusing using x's as multiplication and as a variable. So I'm gonna, going forward, I'll just change that. I'll do parentheses instead. Okay, so now we have 56 times 1/8. Well, we can think of 56 as 56 over 1, and then use some cancellation. So we can factor out an 8 from both of these. That leaves that as 1. 56, factor out an 8, we can get 7. So you're left with 7 over 1 times 1 over 1, which is just 7. And you probably already knew that 8 times 7 equals 56. That's fine. Again, this is just getting in the habit of going through the process and showing the steps, because as things get more complicated, we're going to need to know how to do this. So, and then just like with our other problems, we need to check our answer. So x equals 7, we would substitute into here. 8 times 7 equals 56. Yes, that checks out. Next example, 3/8 y equals 1/5. So here's where it makes a little more sense to use that reciprocal, because we have fractions on both sides of our equation. So I'm going to find the reciprocal of 3/8, which is 8/3. I'm going to put that in parentheses, and we're multiplying it by 3/8 y. And what we do to one side, we need to do to the other. So I have 1/5 over here, and now we're going to multiply it by 8/3. So here, our coefficient is going to be canceled out by that reciprocal, and we're left with just y on the left side of our equation. And then over here, we have 1 times 8, and then over 5 times 3. So y equals 8/15. Now let's go ahead and check our answer by putting our solution into our original equation. So I'm going to rewrite this 3/8. I'm going to put parentheses for the solution that we're plugging in, which is 8/15, and set it equal to 1/5. Now we can do some cancellation here to simplify this. Factor out a 3 here, and then I'm going to factor out an 8 from both of those. Those just turned into ones. So now we're left with 1/5. When we simplify, 1/5 equals 1/5. That checks out. So again, our solution is y equals 8/15. Okay, next is division rule for equations. So this is just going to be the opposite of our multiplication rule. So both sides of an equation can be divided by the same number, except 0, without changing the solution to the equation. This is called the division property of equality. And then my slide is wrong here. This should say divide. So divide both sides. Just going to put a D there. Divide both sides of the equation by the coefficient of the variable in order to solve. So let's just take a look at a couple problems like that. Oops, I already had the answer on there. Okay, so here we have 8x equals 56. This is one that we looked at before. So before we were multiplying by the reciprocal, 1/8. Well, it would be much simpler in this case to just divide both sides by 8 right off the bat, because when you do 8 divided by 8, that's 1, which means we're left with 1x here. And what I do to one side, I need to do to the other. If I'm dividing by 8 here, I need to divide by 8 over here. So we simplify for our next step. We're left with x equals 56 divided by 8 is 7. And that's much simpler than using that multiplication rule with the reciprocal. And of course, we can check our answer by plugging our solution, 7, back into our original equation. 8 times 7 equals 56. So when we're trying to solve equations, how do we decide which rule to use? Because obviously you will get the same answer no matter which rule you use, whether you use the division or the multiplication property. How do you know which one to use? Basically, just look at it and see which one's easier. Just like when we looked at that last problem, it just looked easier to just divide by 8 instead of multiplying by the reciprocal. So for example, like this problem here, this one we're probably going to want to multiply by the reciprocal rather than dividing by a fraction. That makes more sense. And then for this one, 5y equals 45, this is another one where we would use that division rule and just quickly divide by 5. And then for this last one, 12x equals 3/7. This one would probably be a good idea to multiply by the reciprocal of the coefficient. So multiply by 1/12 to cancel that out here, and then you have the fraction over here. That would be the easiest way to go. So just think about that when you're looking at your problems. You can pick which way you want to do it. There usually is one is more simpler than the other depending on the problem, so just pay attention to that. Here are your practice problems for today, so go ahead and pause the video, work on these on your own. So we want to solve each equation by multiplying both sides by the reciprocal of the coefficient of x, or by dividing both sides by the coefficient of x. Again, find the way that works easiest, is the simplest way to go. And pause the video, and then we'll check your answers on the other side. Okay, first problem. We have 5 over 11 times x equals 7. So here we're going to want to use the multiplication property. So let's multiply both sides by the reciprocal, which is 11/5. And I'm going to use a dot for my multiplication symbol this time. And what we do to one side of the equation, we need to do to the other. So we need to multiply by 11/5. Oops, 11/5, okay. And then our next step is to simplify. These fractions will cancel out. So we're left with x equals 77/5. And then we can go ahead and turn this into a mixed number. So 5 goes into 77. Let's see, 1, 15 and 2/5 is our solution there. And we can go ahead and check our answer by plugging this value back into our original problem. However, when I do plug it in, I am going to just use that improper fraction form just to make it easier. So we have 5/11. And then I'm going to put parentheses around my solution that I'm testing, and set that equal to 7. So here we can simplify by canceling out there. Here we can factor out an 11. That gives us 7. So we're left with 7 over 1, which does equal 7. That checks out. Next problem, 3x equals 15. This one, obviously, we want to use the division rule here. We want to just go ahead and divide both sides by 3 to isolate that variable. The 3's cancel out. We're left with x equals 15 divided by 3, which is 5. And of course, we can go back and plug that in. 3 times 5 does equal 15. Next one, we have x over 3 equals 5. So here's one of those examples of a coefficient that isn't really obvious, but in this case it would be 1/3. So I'm going to just pull that out. Well, actually, I'll keep it like this. X over 3. What we want to do is multiply by the reciprocal of 1/3, which is 3 over 1. So I'll go ahead and multiply that by 3 over 1. And set that equal to 5. And to keep it balanced, we need to multiply this side by 3 over 1 as well. So then our coefficients cancel out. We're left with x equals 15. Check our answer. 15 goes in for x. 15 divided by 3 equals 5. That checks out. And last one, we have 4x equals 1/3. Here, since we have a fraction, it would be a good idea to use the multiplication rule, because if we use the division, we'd be dividing by 4 here, which is fine, but then we have 1/3 divided by 4. So I would go ahead and use the multiplication rule. So our reciprocal to 4x is 1/4, so we're going to multiply that. I'm going to use a dot for the multiplication. And remember, 4 is like having 4 over 1. Okay, set that equal to 1/3. To keep it balanced, I need to multiply the right side by 1/4 as well. So then on our left, to simplify, these will cancel out. We're just left with our variable x equals Simplify over here, 1/12. And then we can check our answer by plugging in to our original equation, 4 times 1/12. Set that equal to 1/3. Make sure that that works out. So we could cancel. We would get 1/3 here. So then, yes, we are left with 1/3 when that simplifies, equal to 1/3. Checks out. All right, so to sum it up, keep the equation balanced just like a scale. What you do to one side, you need to do to the other. And you go ahead and use whichever rule is easiest. Math does not need to be more difficult, more complicated than it needs to be. So just keep it simple. And then always check your answers to make sure you're on the right track. That's all for today, so go ahead and do problem set 40 and then read lesson 41 in your textbook. Have a great day and see you next time.